Okay, this lesson is on vector components and some physics problems that we use in this course. And so the first thing I want to talk about is a vector. And a vector is represented by an arrow in the direction of movement or whatever force is going on. And the length represents the amount of force or speed that is being used. So I'm going to call this your vector. It can be broken down into a horizontal and a vertical component. And so basically, if you make a triangle out of it, this would be a right angle. This bottom side would be considered the horizontal component. Or sometimes they'll say the component in the x direction, because obviously the x-axis runs horizontal. This component, this side, would be the vertical component. And sometimes it may be talked about as the y component or in the y direction. So just keep that in mind as you're going, again, because like the y-axis is vertical. This vector is pointing in a different direction. You have to think of it kind of like it were an obtuse angle. When you break it down, its triangle would be here. And so this would be your vertical side and this would be your horizontal side. So this would be kind of the obtuse angle case. Okay, first problem, we're going to find the horizontal and vertical components of a ball thrown at 20 feet per second at an angle of 32 degrees above the horizontal. So we start by drawing our vector, and you kind of have to estimate 32 degrees. So if we have a horizontal line, we'll say this is our vector and this is 32 degrees. So this vector is 20 feet per second. And then I want to draw my two sides that are my vertical and horizontal sides. Okay, and then I go back to sine, cosine, and tangent to find these. So I'm just using standard trig. In this case, I have the hypotenuse. I need the opposite side. I'm going to do that first. Opposite and hypotenuse go with sine. So sine of 32 is v over 20. And I'm going to multiply by 20. They cancel out over here. And then I can type in 20 times the sine of 32 and get 10.59 feet per second. I also need the horizontal, and the horizontal is the adjacent side. So I'm going to use adjacent and hypotenuse, which go with cosine. So I'm going to write cosine of 32 is h over 20, because it's adjacent over hypotenuse. Again, I'm going to multiply by 20. Cancel those out. And then 20 cosine 32. Type that in my calculator. Make sure I'm in degree mode. I get 16.96 feet per second. And those are my vertical and horizontal components. These are in feet per second because we were doing a velocity or a kind of a speed, but a velocity gives us direction too. So this was feet per second. The answers are feet per second. Okay, number 2 says find the displacement in the x and y directions if I walk 900 feet at an angle of 40 degrees north of due east. And this is just a distance displacement type of problem. It's not velocity, so it still works out the same way. We want the x and y directions. That's your vertical and horizontal components again. So I am doing 40 degrees north of due east. So if due east is this way, north of it would be up, so we're looking at a 40-degree angle here. And I'm walking 900 feet. Okay. Then I want to find, again, my horizontal and vertical components. So vertical is up and down, horizontal is flat. And I'm doing the same thing. I'm just using trig. So again, I'm going to let's do this. Since they called it x and y in this problem, instead of horizontal and vertical, let's call them x and y so that we answer them correctly. So if I want to find y, again, it's the opposite side. I have the hypotenuse, so I'm using sine. So sine of 40 is y over 900. Multiply. And then if I plug that in my calculator, I get 578.5 feet. I want to find the x direction, so that would be the adjacent side. Again, I'm going to use cosine for that. So cosine of 40 would be x over 900, multiply by 900. And that's going to give me 900 times the cosine of 40. Type that in my calculator, and I get 689.44 feet. Okay, the next thing that we're going to talk about is projectile motion, which is a definite physics topic, but they've put it in this course because, I guess, of the applications of it. The only thing is, since I teach physics as well, I'm going to show you the way that we do it in there because I think it's the easiest way. So, projectile motion is when you throw something in the air or jump in the air and it comes back down. So, we have a path that looks like this, or, you know, you can go straight up and straight down, and this would still be a height over time path. So, if we think about this for our projectile motion, and again, this is things like shooting a ball out of a cannon, or shooting or tossing a football down the field, something like that. Here's your path. You're going to have to know a couple things. First of all, the height is often going to be something that is asked about. I'm going to call that little d for the distance from the ground, and because we're going to use that in a formula in a minute. The time it takes to go from the very beginning to that highest point we're going to call t, and because if this were perfect, this is symmetrical, the time it would take to get from the highest point back down to the ground would also be t. So if this takes 5 seconds, the whole thing would take 10. Now that helps us because you have a formula. That distance, that height, there is 1/2 9.8, or g, t squared. Okay, and that t does still represent that half, that first half. The other thing they're going to ask you about is horizontal distance traveled. So if I throw the football down the field, how far did it go? I'm going to call that big D. So that represents this big distance. And I'll even do this. That is just like from previous classes, distance equals rate times time. The rate that you're going to use is the velocity in the horizontal direction, so you'll need the horizontal part of that component. And the time it's in the air is both of these t's. So rate times time, the time would be 2t. Something also that you can do to find that t is do the vertical velocity, which is how much is being thrown up with what speed it's being thrown up, divided by 9.8. So you have three formulas here. This little d will give you the vertical height. T will give you that time for the beginning to the tallest point. And then the big D is from the beginning to the end, that distance traveled, the horizontal distance traveled. These are unfortunately things that you need to remember. I'm going to do an example in just a moment that asks about everything that could possibly be asked, and this is probably one you're going to want to rewind and watch a couple times and remember to watch before the test. Okay, so here's our example. A ball is thrown at an angle of 35 degrees with an initial velocity of 63 meters per second. Now this velocity is velocity at an angle. So to get the vertical and horizontal, which they're asking in A and B, we're going to have to do trig like we just did before. And again, it's the 35-degree angle. There are quite a few more questions, but we're going to start with that, and at least it's what we have been doing. So we have the vector that's at 63 meters per second, and I'll go ahead and just do this one triangle. I'll write both of them here. You have the horizontal here, the vertical here, and we're at an angle of 35 degrees. So the initial vertical velocity is this side, so I'm going to be doing sine. So sine of 35 is V over 63. I'm going to multiply by 63 and type that in my calculator. I'm going to get 36.14 meters per second. That is your vertical velocity. Okay, so that was the V sub V that I had in the formulas up there. The horizontal velocity, using the same picture, will be cosine because it's the adjacent side. So I'm going to write cosine of 35 is h over 63. Then I'm going to multiply by 63, cancel those out, type this in my calculator, and h will be 51.6 meters per second. And that's my horizontal velocity. That's the one I used on that horizontal distance, like the length of the field that we threw. Okay, next question. When does it reach the highest point? That's a time. I gave you that formula. The time equals the vertical velocity over 9.8. The vertical velocity is what we found in part A. So 36.14 divided by 9.8. Type this in your calculator, you get 3.68 seconds. So this is a pretty high throw to take that long. Okay, moving on, the next question, how high does it go? That's the little d. So that's the d equals 1/2 9.8 t squared formula. So if I plug in 1/2 9.8, my t that I just found in part C is the same here, 3.68. Just got to remember to square it. Type it in your calculator. You get 66.35 meters. That's how high it goes. It's very high. All right. Next question. When will the ball hit the ground? Well, as we drew in that picture, it was t here and t here. So this is an easy one. You just multiply 2 times the t that we found, because that's its whole path. So 7.36 seconds. That's what it takes to travel its path. And then the last one, how far will it travel horizontally? That's that bottom part, the big D. So that would be the big D equals the horizontal velocity, which is what we found, I believe, in part B, and then that whole time 2t. So horizontal velocity was 51.6, 2t we just found, 7.36, and then I just multiply those together, 379.776 meters. So that's how far it traveled horizontally. So this was launched. Anyway, again, this problem is one that you're going to want to look at again and again, because the math is simple. You just plug into the formulas. The thing that you have to do is remember which formula to use when, or what it gets you, what information that formula gets you. And so figure out a way to separate that stuff. If you have to redraw the notes and remind yourself where the formulas go, find a way to try to remember how to use those. And that concludes this lesson.